So today we are going to be talking about segments of circles. Okay, there's multiple types. I'm hoping by the end of this video you're going to be able to find the lengths of missing segments, whether or not they're chords, tangents, or secants. So the first one we're going to look at is when two tangents are meeting at a vertex. Okay, so as you can see on the left, we have a picture where we have two tangents. So this I'm going to label. I'm going to have A, B, and C. Okay, so we have a tangent AB and a tangent BC. Okay, this is known as our ice cream cone because it kind of looks like an ice cream cone, right? You have your circle at the top and the cone at the bottom. So the formula here and the trick to remember is going to be that they're congruent to each other, or they're equal pieces. So I'm going to have AB is congruent or equal to, okay, BC. Okay, so for our ice cream cone, it means they're equal. So let's use this in an example. Okay, we have our two pieces, and remember they are going to be equal to each other or congruent. So I'm going to set them equal. So I'm going to have 2x plus 4 equals 22. Subtract the 4 from both sides. We get 2x equals 18. So x, if we divide by 2 on both sides, x will give us a value of 9. Okay, now remember a tangent is a line or a segment that touches the circle in one location. Okay, so let's look at another example. Okay, so here, this time we don't have any exact numbers, but we do have two pieces that we can again set equal to each other. So 2w plus 15 equals 5w minus 12. Now we're solving an equation, so remember you want to make all your letters on one side and place all of your numbers on the other. Okay, so I'm going to subtract my 2w to the other side. So I get 15 equals 3w minus 12. Then I'm going to add the 12 to the other side. So I get 27 equals 3w. Divide by my 3, because again, I want my w by itself. So w equals 9. Okay. So again, these are our tangents, which are our ice cream cone. Okay. They are our ice cream cone. The next set of segments we're going to look at are going to be a chord and a chord. And the trick for remembering this is PP. Okay. So PP actually stands for part times part. Okay, so our formula is actually going to be our part times our part being equal to our part times our part. And what I mean by that, okay, is we have a part of a segment here, so that's this part. Then we have a part of a segment there, being that part. Then we have a part of a segment here, being this one, and this part being that one. Okay, so we multiply each part by each other, the ones on the same line, in order to give us our value there. This is why we call this PP. Okay, so let's look at an example. Okay, so here I have one part of a line and the second part. So 5 times x equals, and I have one part of the line, so 4. The other part of the line is 10. Okay, remember the formula is part times part. Okay, so I'm going to have 5x equals 40. Divide both sides by 5. And x equals a value of 8. Okay, again, this is PP. You use PP when we are trying to find a chord. Okay, let's look at one more example with chords. Again, we're still using PP. So part times part equals part times part. So I have a part here which is 5. The other part of the line is 6 equals a part of a line which is 2 times the second part of the line which is x plus 1. Okay, now the left side is pretty easy. 5 times 6 is just 30. Okay, now on that right side, we have to make sure we distribute our 2. A lot of us like to forget that, so really make sure you're distributing. So you're going to get 2x plus 2. Okay, again, now I'm solving for x, so I'm just going to subtract 2 from both sides. So 28 equals 2x. Still solving for x, so divide by 2. And our x has a value of 14. Now remember, if we're solving for chords, we're using PP, or part times part equals part times part. Now the next set of segments that we're going to look at is going to be secant and secant. Now our abbreviation for this is going to be wee, okay, where the W stands for whole, and the E stands for exterior. Okay? So our formula is going to be whole times exterior equals whole times exterior. Okay, so the whole part of the top segment would be from endpoint A to endpoint B. Okay, the exterior is going to be from C to B. Okay, so this is our E, this is our W. The same thing happens for the bottom line. So from F to B is our whole. Okay, and then from D to B is our exterior, because those segments are on the outside of the circle. So exterior means outside. Okay, so let's give this a shot. Again, we're using wee, so whole times exterior equals whole times exterior. Okay, so on my first line, I'm going to label my whole in blue. Okay, notice here that the whole is from our endpoint to our endpoint, and we have a value of 8 for the exterior, okay, and an x for the interior. So to get the whole, we must add them together. So we get 8 plus x for our whole, so I'm going to have 8 plus x. And then for our exterior, it's just that value of 8. It's going to equal the whole on our second piece. Again, we have the interior piece being 12 and the exterior being 6, so we must add them together. So 12 plus 6 gives us 18 times our exterior, which would be 6. Remember, exterior is outside. So again, we have to make sure we're distributing the 8. So we will have 64 plus 8x equals 18 times 6, which gives us about an answer of 108. Solving for x, we're going to subtract 64 from both sides. So we get 8x to equal 44. And we're going to divide by 8. So here, x equals 5.5. Okay, it is okay to get a decimal. That is fine. All right, let's try this one more time. Again, we're using whole times exterior equals whole times exterior. So my whole value here okay, is going to be a little more challenging to find because they're telling me that from here to the outside of the circle there is a value of 4. So the radius is 4, but we actually need the diameter. So if we need the rest of this, we have to add another 4. So our whole piece will be 4 plus 6, or 14. And our exterior piece will be 6. For the other line, our whole piece will be 8 plus y, where our exterior piece is just 8. So I'm going to set up my equation. I'm going to have 14 times 6 equals 8 times 8 plus y. Okay, so 14 times 6 gives us a value of 96. Apologize, that actually is not 96, but it is 84. Okay, so 14 times 6 is 84. Equals, distribute the 8. So 8 times 8 is 64 plus 8y. Subtract 64 from both sides, and we will get a value of 20 equaling 8y. And when we divide both sides by 8, we get a value of, we're going to get a value of 2.5. And it is okay to get decimals, okay? Now we use wee when we're talking about a secant and a secant, okay? The last set of segments we're going to look at is going to be a secant with a tangent. Now the shortened version of that is going to be called wet, which stands for whole times exterior. Okay, so whole times our exterior times our tangent squared. That's why there's two t's, right? Tangent times tangent is the same thing as tangent squared. So our formula will be whole times exterior, that's on that secant line, equals tangent times tangent, or tangent squared. Okay, so let's put this into action, our first example here. Again, whole, so the whole value of the secant will be 6 plus 2, which would be 8. So 8 times our exterior, which is 2, times our tangent, so this is our tangent, squared. So we're going to have x times x. So 16 equals x squared. If something is squared, we must take the square root, because the square root is its inverse. So take the square root of both sides, and we will get x to equal, technically plus or minus 4. Okay, but can we have a negative value for a distance? That's something that we cannot have. So therefore, x will just equal the positive 4. Okay. Our last example for today is going to be this secant tangent. Again, we're using wet. So whole times exterior equals tangent times tangent. So my whole here is 5 plus z. My exterior is 5. So I have 5 times 5 plus z equals my tangent. So 10 times 10. Distribute my 5. So I'm going to have 25 plus 5z equals 100. Subtract 25 from both sides. And we get 5z equals 75. Divide by 5. And z will equal 15. Okay, if you have any questions on this, please write them on the sides and ask me in class. Thanks for watching, and please rewatch if you're confused.